Okay, Dr. White, thanks for the introduction, and good afternoon, good morning, everyone. I'm very glad to be here to present our work, and thanks for you are still here. I'm a PhD student from Fudan University. The work I'm going to present is the association study between intelligence and cortical thickness in adolescents using the adolescents brain cognitive development dataset. I will show from these 5 aspects. The relationship between the intelligence and the brain morphology is warmly concerned in cognitive field. General intelligence can be defined as the weighted sum of fluent and crystallized abilities. Fluent abilities are more depend on genes and gene expression. Crystallized intelligence, in contrast, more depends on experiences. However, the biological foundation of the human intelligence remains to be reviewed. We aim to identify the association between the intelligence and cortical thickness in adolescents, both from commonality and individuality. In our study, by utility, the structure MRI from a large sample of the ABCD study, the largest cohort in brain development and children health in the United States, we used the NIH box cognition composite scores, which include these 7 items. This results in 2 measures of crystallized abilities, as well as 5 measures of fluent abilities. And we extracted the cortical thickness according to the Industrial Atlas from Free Surfer. Then, we model the mean and the dispersion between thickness and intelligence using double generalized linear model, which it roughly fit the generalized linear model of the mean parameter and a second generalized linear model of the dispersion parameter on the deviance of the first model. The biggest difference between this method and the traditional linear model is that it models the variance at the same time, and it assumed that the variance is not a constant but a function of the independent variables. Age, sex, and set are considered as covariants in the models. Herein, we use the generalized addictive model to remove these effects. To correct the multiple comparisons, we employ the false discovery rate correction. And we also use the elastic net regression to test whether cortical thickness can predict different kind of intelligence across subjects. Elastic net enables data-driven regression analysis by enforcing sparsity of regression output values. In this place, alpha sets the degree of mixing between range and lasso regression, and beta is the shrinkage parameter. Our study included among 10,000 subjects after quality control for free surfer and removed subjects with lack of cognitive scores. The samples include 22 sets. Sex, age, and mean thickness information are listed in the table. We also analyzed the correlation between the different scores and the covariance. There are our results. In the mean model, we found that crystallized intelligence are more associated with cortical thickness than fluent intelligence. Some frontal, temporal, and perimeter regions, especially orbital regions, gyrus, and central postcentral gyrus sulcus are positive with intelligence. Occipital regions, especially coloring and middle occipital temporal and lingual sulcus, parahippocampal gyrus are significantly positive with crystallized intelligence. However, some frontal regions, such as superior frontal gyrus, middle frontal gyrus, exotic, and paracallosal sulcus thickness are negative with intelligence. This result is consistent with Zhao's Nature paper. They found that the average intelligence children reached a peak of cortical thickness at age 7 or 8. Highly intelligent children reached a peak thickness much later at 13 years old, followed by a more dynamic punching process. And ABCD data set samples are among 9 to 12 years old. In dispersion model, we found interesting results that all the intelligence scores are negative associated with thickness, which may reflect that higher IQ population are more similar in brain structure than lower IQ population. And the fluent intelligence is more negative associated with thickness dispersion than crystallized intelligence. Crystallized intelligence is more associated with dispersion in left hemisphere cortex regions, and fluent intelligence is more associated with dispersion in left hemisphere cortex regions. And in the cross-validated elastic negative regression, we set an alpha value to 0.5 to take advantage of the relative strength of the two regression methods. The cortical thickness accounts for about 10% of the total variance of total intelligence score. This R-square value was significant using permutation test. In conclusion, we use ABCD sample cortical thickness and cognitive score to analyze their association, both from mean and dispersion aspects, using double generalized linear model. Using this model, we can get two model results. The mean model results are almost the same as generalized linear model, that different brain regions have different priorities with intelligence in development process, and higher IQ adolescents frontal region develop later than lower IQ population. Mostly, the development of the left and right brain is balanced. The cortical thickness accounted for about 10% of the variance of the adolescent's intelligence. In the dispersion model results, we found that higher IQ population are more similar, or we can say lower heterogeneity or variation in brain structure than lower IQ population. The heterogeneity in crystallized and fluent intelligence have obviously brain asymmetry. This phenomenon may reflect that crystallized and fluent intelligence can be studied from another perspective using the double generalized linear model. Our next step, we will detailedly further analyze the association between other brain morphology, such as cortical area, cortical volume, and subcortical volumes, and fluent crystallized total intelligence. And here, graphically classify the samples from age, sex, and intelligence to figure out whether there are difference patterns. After this, we may use other genes data to explore the genes influence to the both. Many thanks to my advisor, Jianfeng Feng, and our IST group members. Thanks all for your listening.